accepted.
All right. Wow, that was quite an intro, especially for in the morning. So, dzień dobry, good morning, guten Morgen, and hi and welcome to this talk about why you want to code with Quarkus. So it's going to be a Quarkus session. It's going to be a live coding only session to wake you up in the morning. So I really appreciate that you come here at this first talk of the day. And it's a quite impressive hall, I have to say, and I also tried out the seats. So I'm jealous of you. You have the better seats. I have to stand here, so I would love to join. And yeah, I hope you can enjoy the session on Quarkus. I think it's going to be a fun one. My name is Sebastian. I'm originally from Germany, Munich, and I do a lot of stuff in Java, as you can see, so there's some Java titles involved there. I'm a freelancer. I help my clients in all sorts of consultant engagements. I do workshops and trainings, also on this topic of Quarkus. I also do a lot of online stuff. And yeah, basically I have been involved in enterprise Java for quite a while, and now I'm very happy to talk about this Quarkus technology that you might have seen. So the supersonic subatomic Java, if you check out the website quarkus.io, you will see a lot of interesting information. And I want to basically share you my most important, let's say, reasons why I think Quarkus is a very interesting technology to use. And well, as a spoiler, I use Quarkus now in all of my client projects. And well, basically the reason why you want to code with Quarkus, I have to tell you, the native mode is not even on that list, not really what I'm going to show you. So there are some other interesting reasons, and yes, I would like to go right into it. So what we do live coding, of course. I have my code available on GitHub, but it's more important actually just that you watch and follow along to see the points or to see why this is interesting. And to start it out with, why I want to code with Quarkus, I want to point out the outstanding developer experience and especially fast turnaround times. Who of you has tried Quarkus before, especially this dev mode? Hands up. Okay, not too many actually. Okay, those of you who have tried, I'm pretty sure know what I refer to. This is actually quite fun when you try it out. Just give it a try and you will see why this is an interesting technology. So what I have here is a Quarkus project or a Maven project that is called Playground. I like coffee. So I'm very happy that actually outside, if you watch and attend some of the conference booths, you can get a lot of good coffee, which I really enjoy. Also, Krakow has a lot of nice cafes, which is nice. So I will have some coffee examples in this demo. And what this is, it's just a very basic Quarkus application here. This uses Quarkus in the latest version, 3.1 and JDK 17. Who of you uses a recent Java version, at least 17 in production? Hands up. Oh, okay, a lot. Okay, more than expected. That's good. That's good. So if you are on 11 or if you're on 8, please update to something more recent. And yeah, that's what we're going to do. Basically, what I want to show you, and I'm pretty sure you have seen something like that, is if you build the project Maven, it's this Quarkus :dev development mode. So what this is basically a Maven plugin that is called Quarkus Maven Quarkus plugin. That what does it do? It starts up the Quarkus application in an interesting way, and it keeps the connection to the code. So rather than building the application and just running it using Java or using some other mechanisms, which we'll see in a second, it will just start it out in a way, localhost 8080, and keep the application running and also keep the connection to the code. So if I say I now go to curl localhost 8080 and something like /hello, I will get some hello world response here, hello world, which of course is served by some resource. So I have a very basic hello resource that shows just my Java code here. To you, this shouldn't be too surprising. So what Quarkus has, and I think that's a great point, we'll come to this as well, it has the support for a lot of known APIs. What this is JAX-RS. In the past it was JavaX, and now it's the Jakarta from Jakarta 10 package. I'm pretty sure you know this API. If you are a Spring developer, then this is very similar to a Spring REST controller. It's just like hello and all of these things. very typical and known programming model. So even if you're in the Spring world, you're not that familiar with the enterprise Java annotations, very similar, auto-wired, at inject, application scoped, at serve as a component. The Spring things always have equivalents here, and this works really well. Okay, so what I want to show you actually is I have another resource that is coffee, and it just says coffee. Okay, so now what if I keep my application running here, I go to this coffee shop and I take this response and I say, instead of coffee, I say coffee exclamation mark. And then what I do, if I have a new request, it very quickly just changes this. So I'm pretty sure you've seen this. It keeps this application running and it says, okay, due to changes in this coffee shop class, it will update everything. And it does it very quickly. I have to say this laptop is more than 5 years old. On my other computer, this works almost even faster in a few hundred milliseconds. So this is quite interesting. What it allows us to do is to actually keep coding while our hands are on the keyboard while we're in this development flow, and we don't have to wait for restarts. Especially if you come from the legacy enterprise world, and I know this a lot. You build your application, you deploy it to some application server, and it takes minutes, sometimes a half an hour to deploy this thing, and you have a lot of waiting time, which is bad. So we would like to avoid this, and what you can do, you can just change something in your production code, you can reload, and you see the changes being reflected. Now, this is a very basic change. I'm just changing a string constant. I know this is boring, but as you will see in a second, this works also with quite sophisticated changes. Actually, you can keep the whole thing running the whole time during your development session. You don't have to care about it. If you make some compilation mistake, doesn't matter. It will just try again until everything works, and you see the change. And this is extremely fast. Now, the other thing that is pretty cool, that I like a lot, is this feature that includes actually a testing way. So I can press some keys here in order to start the test that is called continuous testing, and it will run my tests here. And what I have, for example, have a unit test that checks for the string, which now fails. But the point that the test fails, that's not that interesting, but how quickly it runs actually. So if I press my key and I press it now and now, and now you see it immediately runs the test. This actually works even faster than in my IDE because it doesn't need to start up, you don't need to spin, and then you see the result. You see the result immediately. So for example, if I now go to this test, coffee shop test, and say, okay, I'm going to fix the test by adapting the string as well, then immediately it's passing. I don't even have the time to switch my workspace that quickly. It just it gives me the result right away. So this works quite nicely, this integration. It also, if I stop this again, it integrates with my integration tests. You probably know exclude pattern. You probably know about the notation of an IT, Maven integration test. These integration tests that you have to run differently. They're usually not run with the Maven Surefire plugin, but excluded. But if I set the exclude pattern to 0 or to empty, then it will include them as well. So for example, what I have a system test here, coffee, or an integration test, a smoke integration test, that actually already connects to my running application and checks for the same string. So this is kind of interesting because that's already a much better test. It doesn't just take the code and instantiate. It actually connects to my running application. My coffee shop that is just encoded in this class here, in this delegate. It says localhost 8080, this is configurable. Go to the coffee, get coffee, and make a GET request, and then see if this is equal to coffee. And now if it's not, I can run this again, You see how quickly this runs. I immediately get the result, but this is already the running application. It's not just a code level. This is a real, more integrative test. So if I say, okay, now I change this, and now it's green again. So that quickly. What did it do? It updated the test. It updated the test to match what is there in the application. If I do this again now, if I say I change the running application from coffee, question mark to, well, just coffee or whatever, now immediately my tests fail. Both of these tests, if I now change my, where is my coffee shop test? Here, then only one test fails. You see how quickly this works. And this is already an integration test. And this is thanks to the connection to the code that Quarkus has, so I don't need to wait, no matter which type of tests you're running, which is very interesting. and we can talk about this more. This is a very interesting topic, or if you have some questions at the end of the session, if we have time for that. So basically, for the fast turnaround time and this developer experience, this comes quite nicely out of the box. That's also the cool thing. This has been shipped since the beginning of Quarkus, so it is integrated really well. If you try this out, you will see it works really well. It's not just some workaround that has been added afterwards. It has been baked into Quarkus. So this comes also in some other things. So for example, it starts a debug mode. If, for example, I say I would like to set some breakpoint here and say, okay, now I'm going to connect my application to what's that? Local, oh, that's too small for you to read. Local host 5005 port, that's the default remote JVM debug port, right? And the thing is, my application is already, no, it should say it somewhere. It's already connecting to this. At the startup, it said it was waiting for the connections on the, oh no, I think is it somewhere here? Yeah, 5005. So it listens to this debug port. And now if I connect to this, then I can just, well, invoke this again. I think that was the coffee, right? And now it's capturing the breakpoint, which is also just nice for debugging, right? It has the debug capability already enabled. You just have to set a breakpoint, connect, and it's there. So the tooling here is really, really nice from this perspective that you don't need to do much. Let's stop this again. You can just debug and see and try it out. So for a local development experience, I think this is pretty much the best that you can get out there in the Java ecosystem. You can try this out yourself for different tools because it doesn't make you wait. So the idea is that you start up such a development session at the beginning of your working session, and while I'm working, I don't want to wait. And this is really important because if we have waiting times, even if they're just a few seconds, what happens? Well, we get bored, we get annoyed, right? If I say, for example, I have something that takes 1 second, right? So I press something, I press a key, I wait for my test, now it's done, right? That's usually okay. You press, you wait, okay. You will wait for it. You won't, do something else. You won't leave the room. 1 second is okay. If this becomes, 2 seconds, then this is already my threshold for which I say, okay, I will still, synchronously wait for it. So it's kind of like, okay, now it's done, right? It's like a blocking method call. You will still wait for it. But now, if you say, okay, you have just a very quick build that takes 10 seconds, or your whole integration test suite, like 10 seconds for most integration test projects I'm in, at least 10 seconds is quite fast still. But for me, this is too slow. Why? Oh yeah, let me check my phone. I haven't looked at mail in a while and Slack, and this is what happens, right? If we have waiting times, now it's done. If we have waiting times that are just too slow, too long, that make us wait, what happens? We get distracted, right? Of course, then we look around, we check our emails, and then our attention is gone. So while you're developing, while your hands are on the keyboard, it's very important to keep the short turnaround times, to not make you wait. Like even 2 seconds, that's the maximum, that's the threshold. And with modern technology, that's not even about Quarkus, but just in general, you can build up such a way that doesn't make you wait, that actually has this very fast turnaround time. There are some ways to do this, also with testing. That's a big topic on its own. If you want to check this out online, I have content on that, how to make efficient test suites that really doesn't make you wait. So that's an interesting topic as well. But this Quarkus development mode helps you a lot. This is integrated really nicely. As you can see, also there is a remote dev mode. It even works in containers. It works remotely if you want to connect to some running Quarkus application. This works as well. That's kind of cool. But in general, I don't want to sell it to you. Again, I'm self-employed. I'm a freelancer. I'm not working for any of these companies. But just try it out yourself. This is really fun. I mean, if you give this a try, you can go to the website Quarkus. You can go to code.quarkus.io, then you can generate a project and then just try it out yourself. This is really, really fun to do. So that's actually, I think, one of the most important reasons why to try out Quarkus as a developer, the outstanding developer experience. Now, another reason why this might be interesting, it comes with known APIs. So it's not that Quarkus tries to, like other enterprise frameworks, tries to reinvent the wheels. I mean, how many HTTP RESTful APIs to build these services do we have in the Java ecosystem, right? But it actually uses the things that has been out there for years. Actually, the building blocks of Quarkus are known technologies that have been mostly in the Red Hat ecosystem for many, many years, like Hibernate, like Wildfly, Small Rye. It builds on these building blocks and it uses the same APIs, which is very good for us if we have either existing projects and or existing knowledge. So if we know how JAX-RS works, you maybe have seen these annotations before. If you know how CDI works or JPA, you can just use this right away and you will be productive quite quickly with Quarkus. The same if you have an existing project. So I've been involved in a few migration projects for my clients, and it was surprisingly fast to migrate that to Quarkus, because for most of the business logic code, if you have been sticking to the standards, you don't have to change much or anything at all for most classes. You just take them, they are also valid in the Quarkus ecosystem. You need to change the runtime and the configuration, but then that's that. Microprofile, same story. Spring with a caveat, so there are some Spring annotations supported. Of course, you cannot just take a Spring application and run it with Quarkus, but you can take some of the Spring code, because a lot of the annotations are very similar, right? Like what they do. So add component, add service, add auto-wire. There is a pendant there in the Enterprise Java world as well, or in the Quarkus world as well. And you can do this. So you can actually take a Spring migration project and have the support for these annotations and migrate it quite quickly to a Quarkus. That's kind of interesting. All right, but I want to show you a little bit more live coding, and I think this is also kind of fun. So let's have a look at persistence, and especially what I'm going to use is JPA and Hibernate. I'm pretty sure you know these words. But also this new thing that is called Quarkus Panache, which is a nicer way to do this, a little bit similar to Spring Data JPA repositories. So what I have here in my application is this coffee. So I'm in this coffee world here, and I have this coffee class. So basically, I can ask for coffee orders. How this works is I can go to localhost 8080, I say coffees, plural, and I get a JSON response of my coffee orders in the system. So that's an empty array. There is no coffee in the system yet. But I can change this. I can basically go to this coffee resource and check. I can get some coffees and create some coffees, and I use some JSON to create some drink type. So just like outside, if you go to one of these booths, which I really recommend, it's nice. People will ask you which type of coffee you would like to have, and then you can say you would like some espresso or some cappuccino or whatever. So you can just order a coffee by bad request. Yeah, of course. If it's too early, I cannot write JSON yet. So if you post this to the HTTP API, it tells you 201 created. So now you just created. Let me do this again so you see it properly. It sends a post request to here, and then it creates the coffee. OK. So I now just created, I think, 2 coffees, which now should be in the system. Here, if I ask this again, now I get these 2 espresso, or espressi. All right, so that's in the system. That's quite straightforward. That's basically just a Hello World REST example here with some links. OK, now this, of course, is not persisted yet. So if I stop my application and start everything, then if I check this out in my coffee shop here, you will see this is only stored in memory in a hash map, which, well, yeah, is fine for testing purposes, but not more. So if I go to my system again after restart, it's empty. So of course, I would like to add some persistence. How to do this? Well, there are a few ways that are supported in Quarkus, and you can check out the Quarkus guides, which are quite helpful here for example, persistence. And then you can check out here simplified Hibernate ORM with Panache, for example, would be a good guide to do this. That is, well, Hibernate ORM is JPA implementation. I'm pretty sure you know about this. And then it tells you a few different ways how to do this in a nice way. Now, typically, what we need to do in a Quarkus application is to add some dependencies. This is a little bit similar to the Spring Boot world. So we add a dependency for Quarkus. This is called Hibernate ORM Panache. It's the one that we want. You don't have to have a version. We have a parent here. The cool story is the Quarkus development mode will even check your updates in the POM XML. You don't even have to restart it. And if it's not there, it will even download it for you. So now you see, okay, it was quickly restarted, and now the Hibernate ORM and Hibernate ORM Panache feature is active. I can already use it. So, you're seeing this very quick. But what I also need is some sort of database driver. So I have a JDBC driver I want to use Postgres. And I can add this here, and then I can say, okay, please make this available, and then I can connect to a database. Where do I get a database from? Well, there are different ways. Now it's trying to pull this, what I'm going to show. Okay, let's see if this works. Conference Wi-Fi. There are different ways to do this. I could start the database just with a Docker container. I could, use Docker Compose or whatever. But what is there out of the box, which is very helpful, that is called dev services. If Quarkus sees, hey, you're configuring a dependency for a Postgres database, but you obviously don't have any, or you didn't configure one, here is one. So it will give you one, powered by test containers. It will just start up a Postgres database. Well, it would start up. Please be patient. I actually don't know how long this takes. No, this was the other one. Sorry. It's not started yet. Okay, I think I now just killed the Docker container. 1 second, let me restart this. So what it does, it checks if there is one running or one configured. If it's not, then it will start up one for you. It's the question whether you would like... Oh, now the Wi-Fi reconnected. Okay, now that's going to be fun. If this is actually going to work with dev servers as well. If not, then I will just tell you by talking over it. Basically, now it is. Container starting, okay. Yes, now it did. It did work perfect. What it does, it starts up a database, Postgres, powered by test containers, which is very helpful for just testing purposes. There's a lot to it, if you want to use this approach or another one, but just to get started, I think it's nice, this dev services. If I say I didn't configure anything yet, my application properties, that's just still empty. So I haven't configured a database, but it saw that I wanted one, because I added this dependency, so we'll just start one for you, which is quite nice. Okay, now we can start coding. I can say, I would like to make this a JPA entity. Now, I'm pretty sure you've seen this before, that I say, okay, just add, entity. Now that's the Jakarta package. I can call this table name, for example. I can say this should be a nicer table name, such as coffee orders, right? Of course, it needs some ID. I have a UUID. This should be a generated value, for example. The string should be just this. For me, these fields are public because why not? I know it looks a little bit weird in the Java space, but it's totally valid because it's just this data class. I can of course make it private and getters and setters, obviously, but that's that. Now I can have this here. Okay, now what does work here, or what can I do? Well, actually, if I restart this, you will see that it will already populate something in a database, which doesn't really help me much. So it will create the schema with Hibernate. But in order to use it, I of course need to use the code somewhere. So let's live code this and change. I throw away the map. I don't need this anymore. I say, okay, how do I get a specific coffee here? Well, in the enterprise Java space, you probably have seen this. I can inject an entity manager, for example. I can do this and do the plain old, entity manager and find and all of these things. If you've used this, you see, okay, it works, definitely. There's a lot of existing code for that out there. It might not be the most convenient way, with an entity manager, with the querying, there are different ways out there, which is why I will use a different way, but it definitely works. The way that I use is what is called Panache repository. So I call this coffee repository. This will be a class, application scoped class, that implements an interface, Panache repository or Panache repository base, which is just a repository for an entity, and per default a long ID, or if I want a different ID type, I can have Panache repository base. I say this should be my coffee class, and it should be a UUID for an ID type. So it will parameterize everything already. And that's already sufficient. I can have this repository just like that and say, okay, great, now I'll go to my coffee shop. I would like to inject this, the coffee repository. and say, now I'm going to use this, the repository, for example, to find by ID, which, thanks to the parameterization, already has the correct type. I say, okay, great, find this by the ID, and then there you go. So this is a very nice approach, and it's even more, convenient than the entity manager, which of course also works. So you can still use this, especially if you have existing code. Okay, but now it shines even more. If I say I would like to have a list of coffee, this was a little bit cumbersome always, with this entity manager, because you need to query something. Maybe you have a named query or a native query and things like that. But here I can just say, well, list. Because a list gives me just a list of coffee that's already this type. It will, list all, I think that's the name, yes. List all will give me the list there, it's the correct type, you can just use it, and then you're done. Okay, now for adding the coffee, for persisting a new coffee, what do I need to do? I need to persist this, obviously. I can say repository, the name is persist. If you read the documentation, it will tell you this persists the entity, it will make it a managed entity, which for us means, okay, then the ID should be populated. So I don't have to set the ID, of course, and I can just return the ID for later use. So that's already that. I can just use this. Okay, let's see if this works. Let's try it out. I restart. I go to my application, coffees. Now this should be empty, of course. I say, okay, post a new coffee shop, coffee order, for example, espresso, what we had before. And of course, I get an exception. As you can see here, the font is a little bit big. If you paid attention, and if you're an expert, you're probably laughing already because you know what I forgot here, right? It even tells you, and that's quite nice, transaction is not active, consider adding @transactional to your method. Yes, of course, I need to have this in a transactional context. JTA, this @transactional method, pretty sure you've seen this before. So I need to add it either to my whole class or just to this method that persists something here. I can just add it here. I say @transactional, and there we go. So that's that. Okay. Let's try this again. Okay, now it works. Great. I just created this coffee here. I can do this again, and now I can query the coffees, and now this should be in database. Okay. There we go, 2. Okay, is this now persisted? Well, kind of. If I go and stop my application, from the application perspective, it would still be there because it uses the database, but because I'm using this dev services database, it will also, stop the database and also drop and create my schema. So, everything is gone after I restart here, unfortunately. So what I can do then, okay, let me just configure this differently. For testing purposes, these dev services are very nice, that it just starts up, it fires up a database. But then if you do some more sophisticated stuff with some data that you would like to have inside and say, okay, I want to, have populated with specific things, it might make more sense to, define your own one. What I typically do, I define it in such a way this uses, this data source URL for local host, that I run this locally. The easiest way for me to do this is just to say, okay, I run this actually in a Docker container. Run database, for example. I say, please start this up, in a plain database there. Run a database as a Docker container locally. This starts up these. The other one will be gone in a second, this test container. And then I can use that. Now, if I, let me stop this again, just for you to see. Now, if I configure a database and I don't have one, then obviously it will fail, right? Because of the configuration, it expects that the database is there, and after trying, it tells you, hey, something like connection refused. It tried to connect to the database that is configured, but it's not there. Let me start this again. So now the database is there, my Postgres database, and now if I restart it, now it should work. Okay, perfect. So that's that, and then I can post my coffee again, and I can even connect to my database and say localhost user Postgres. I see the coffee orders, and I can check the table. Now there should be a coffee order inside. Okay, that's that. It uses it. But the interesting story really is the nice API of this panache, and also the way how now you see in the development mode, this works quite nicely. I can keep everything running. I don't have to wait. I can just keep coding. The same is true if I would like to add some more domain-specific things here. For example, if I would like to have something like a list of coffee, or for example, list all espressos, or espressi, I don't know about the grammar. And then I say this should be something more domain-specific, where I say return not all, but the list just of what you can query. For example, the type is espresso. In case that makes sense. Something like that. I can also inject the entity manager here and say, use this for existing code. You can basically encapsulate the persistence logic into this repository, which from a coding quality perspective is quite nice, I think. So for example, if I would now swap this, if I say get the coffees, list all espressos instead, what I can do, I can say, okay, curl this again, create another espresso, and create a cappuccino. If I query all of, this font is too big. If I query all of my coffees, now it should only give me the espresso and not the cappuccino because it's queries for these, for example. So you can, have some own custom code there, which is just kind of cool. All right, so that's persistence with panache, which is just one particular feature I like a lot. I think that's very helpful and nicely integrates it. You can also mix and match all your existing JPA code. That is also supported. So this is just a nicer way to integrate that. But let's move on a little bit in the Quarkus world. Especially there's one important topic about the whole runtime and the thin deployment artifacts and the Docker and Kubernetes support, which is quite nice. So if I stop my application and just build it normally, usually with something like Maven clean package or Maven clean install or whatever, or verify or whatever one you want to invoke, what it does to build your application is it builds it up in a way that runs a plugin here, Quarkus Maven plugin build. And what it does is the Quarkus augmentation. Okay, so what does it actually do, and what is the killer feature of Quarkus? How is it different to other enterprise technologies? How does usually your Spring application or your application server work in the enterprise world? They usually work in the way that you say, okay, my application starts up, and then the application server or the Spring runtime starts scanning the whole world. That is how it usually works. So why can we actually use these nice annotations? Sometimes it is said, okay, this is like magic. You just throw an annotation on it and then you have a REST control or something like this. No, there is no magic. How does it work? Your runtime scans the whole world. It scans your application, or your application server scans the deployment artifact and looks at all of the classes and scans for known annotations. Because this annotation, this application scope or the at path or whatever, it doesn't do anything, right? It's just an annotation. What? Yes. It is just an annotation. It's like a post-it note that is added to the class. It doesn't have any features or any functionality. But the runtime knows about it and says, oh, add application scope, I know what that is, following the standard. I've seen this before. And the same for all of the other ones, right? Like this add inject, I know what that means. So what your application does, it builds up this meta model, it builds up all of this understanding of what your application should do, and it does so at startup or at deployment time, right? So you start up your application and typically it does this. Now, how is Quarkus different? Quarkus does all of this at the build time. It does this, what is called Quarkus augmentation at build time already. And because of this, you get huge benefits. Why? Because when you start up your application, everything is already optimized. Everything is already there. It is like if you wrote an HTTP server from scratch, without any reflection, without any magic and class loading, just invoking some methods. Just it's already there, like you have the code available. And because of this, if I start up my application, using java-jar, target, it resides under Quarkus app, this directory, Quarkus run, that's the jar. It will just start it up. And this works extremely quickly. I mean, now it is 2 seconds because of the whole database loading and initialization. Usually it would be half a second or less, especially on a modern computer. So this works extremely quickly because all of that has already been done, all of this work. So that's that. Now, If you heard Quarkus, then you've probably seen, okay, there is a way to do this natively. I can have some native builds. And especially there's some comparisons here about all of these things. We will go into that in a second as well. For now, I just focus on Quarkus on the JVM mode. Think of it like a JVM, a Java application. Okay. Now, what did I just mean with the thin deployment artifact and Docker support? Well, out of the box, what Quarkus does, it comes just in this way that it targets Quarkus app. It has this Quarkus run.jar, but as you can see, this is very tiny. It's just 600, byte. It's not even a kilobyte. This is not a fat jar. It doesn't contain everything. It just, starts up your application, and you see there are multiple layers for your application, some libraries, some Quarkus runtime. And why is this the case, you might ask? So why is this so complicated? Just put it into one, fat jar. Well, no, because if you're in a container world, you have something like a Docker file, for example, and then you might say, okay, I would like to add this here in multiple layers. Why would you do this? Well, because then you get a lot of benefits of the container image caching and the copy on write file system, how the container images work internally. What do I mean by this? Well, if I build this, let's call this coffee shop temp. Yeah. Then it says, okay, build everything here. And the first time it takes a little bit, and then if I now rebuild my application, so I get a new jar, and I do this again, the second time it can cache almost everything because the dependencies didn't change. So it doesn't have to rebuild the whole Quarkus world. You can say here using cache, and this already works much faster. Here it is not that visible, but it will be especially visible if I say, okay, do something like a Docker build to my own server. I have an own registry where I can call this coffee shop, I don't know, 1, 2, 3, whatever. And then I would like to push this. If I push this over the wire, now this is brave using this over conference Wi-Fi, but I will actually do this quite quickly. Why? Because it doesn't have to push. How big is the image? Well, probably a few hundred megabyte, right? It includes Java, it includes. Okay, now if the Wi-Fi doesn't work at all, then I cannot show you even this. But you don't need to push these megabytes of images. Why? Because the lower level layers of all of your dependencies, the whole Quarkus runtime and everything, they don't change. Only what changes is your actual classes that you do. Okay, now it worked. So you see, okay, probably changed some of the dependencies at first. The last time I pushed it, it only pushed a few megabyte. If I build this again, then it probably will just push a few kilobyte here. Okay, let's see if the Wi-Fi does this as well, then I can show this. So no kidding, I've actually pulled it and pushed Docker containers via an airplane Wi-Fi before and on trains and on mobile networks. If you just pull a few kilobytes, this works really well. So this is not a big problem. Okay, this didn't work there. Let's see if I can show the other demo there. This is just a big benefit here. So this comes out of the box. You don't need to add anything. I know Spring also has a similar support, but just that is the default way how a Java application is being built. With the Docker support as well, what is quite nice is also the containerization approach. So I won't show you the example running on a Kubernetes environment, but I'm pretty sure you can just get it from looking at something like this. This is a deployment example for my Quarkus application. What you might need in an example like this, where you say, okay, this runs in a Kubernetes setup, then you probably have some different configuration, right? Like your data source JDBC URL is different. For example, I use, okay, let me see if I can connect to my Kubernetes cluster. I have a Kubernetes cluster running on the Google Cloud, the Google Kubernetes engine, and it should already, well, okay, let's see if I can connect to it with the Wi-Fi. It already also runs with a database, so a production-grade Postgres, and I can just configure this. Okay, if it doesn't work, then never mind, but you will see it from the configuration. I mean, the interesting Quarkus part, okay, it does work, so let's see, maybe I can actually deploy it. Coffee shop Quarkus YAML. It runs already a database. This is provided by a Kubernetes operator called Stackress, which is pretty much the state-of-the-art, one of the best operators there for Postgres. So you would just see I run it differently, of course, in a production setup than I would do locally. It runs up my database, already has some, the schema for my coffee orders and things like that. And then my application connects, of course, now to a different database. And what I can do, I can just configure that. And the configuration works via environment variables, via system properties, out of the box. I don't have to do anything. I just define this environment variable. And what it will do, it will override this one, because they have different hierarchies there. So that is quite nice. The integration here, I don't need to do anything else. I can just, oh God, timeout. Let's try this again. Maybe it works. Maybe we're lucky. Oh, yeah. And then once this starts up, then I could hopefully, let's see, access this in my Kubernetes setup, and I can create some coffee orders live here. Okay, let's see if that is the case. But you see the integration is quite nice. What I did here, there are multiple ways how to integrate that. I typically, in my projects, I create the Docker files and the Kubernetes YAMLs myself, because somebody has to manage them anyway. There is also some extensions there where you can just generate this even. I'm typically not the biggest fan for that. But it is possible. And okay, let me quickly try out my my own hotspot. Maybe that works better, just for you to see this demo. But it's not super important. It would just be nice. And that is one thing here. Okay, let's see. So you see, this support works quite nicely out of the box, and then I can do this and use this here. Do we have? Okay, let's see. Pods are there. Okay, perfect. Now this is deployed. I have some load balancer available. This should be the external IP here. Let's connect to this IP 8080, let's say coffee. And yes, it works. Coffees should be empty. And now if I create JSON, if I create my type espresso, here, oops, if I write my JSON, correct? No. You see, that's the fun thing with the live coding. Everything can go wrong, even the typing of the JSON. And if I now query for my coffees, I should get my espresso coffee, perfect. And I should also see this in the database, so I can, connect even to the database. This works with, some Postgres utility, and say, I would like to connect to this. Okay. Give me the tables. Okay, great. Have a look at this table. And there is my order now in my Kubernetes setup. So now this runs in my Kubernetes cluster. Now I have the Quarkus application running here. So this works quite nicely. The support is great. Health checking and all of the stuff that you would need just works quite nicely here. Okay, but the interesting thing is actually the thin deployment artifact support that works there out of the box. That is quite nice. You can just, conveniently and efficiently build these Docker containers. Now, in a few minutes, I think, we should get there if I'm fast. There is another quite nice feature that I like a lot in Quarkus. That is the Qt templating engine, which is, a templating engine. Now you might say, okay, why is there yet another templating engine? We have JSP, we have Thymeleaf, we have some other things. Well, in the Quarkus world, we'll talk about the native mode at the end a little bit. You need, some Quarkus-specific stuff to basically make this available for native builds as well. And what we have a templating engine that is called Quarkus Qt. So that is called, like this, Qt is Quarkus templating engine. So Quarkus Qt is the name. Or we can add REST Easy Qt that already has the integration with our JAX REST Easy. We can do this. And then what we can do, we can have a very nice action-based model view controller way to include this. For example, I can call this now coffee controller. I say I have something like orders in a path, right? So I say orders HTML. This is an application scope bean. This will produce not JSON, but actually HTML. This works. You can use these controllers to produce HTML. And then what you can do is to say, okay, if I get an get response for my orders, I can say, okay, if this is being invoked, I can just return some HTML. Okay, this is now not the point. I would like to add some templating approach. This works with this add location. You can add inject, for example, some HTML file, which will be a so-called template. And these templates, out of the box, they reside under resources /templates, and then the name that you would inject here, orders HTML, for example. And I say, okay, now this should be some sort of, coffee orders templates there. And I say, I have my coffee orders here, right? And then I say, okay, template.render, for example, and then I can have this in my, is this still running? No, it's not. Start this up again. I can have this in my browser by saying, okay, once that is started up, I can, okay, launcher problem, let's see. Oh, compilation failure in my coffee shop test, really? Did I? Let's try this again. Maybe there was some glitch. Okay, coffee order. Now this is boring, I didn't have a templating, this was just a string. Of course, I can do some dynamics here. I can say the syntax looks like that, for, and for example, end for. I can say for each order in orders. I can loop over this. I can, for example, say, okay, have a UL list, and this should be an LI list of saying, order type, for example, something like this. And then, of course, it gives an exception because I haven't added orders here. So how this works typically in action-based MVC, that I need to add this as some sort of data, and I say this should be called orders. And the orders, of course, come from somewhere. They come here from my coffee shop that I can inject. So you see, this programming model, I think, is just quite nice and straightforward. Get coffees, for example, should then be my orders that then can be added here. This would either be a string or a template instance. That's a different type that is also supported in this JAX-RES integration, for which I then can say, okay, now please list these orders. Okay, espresso, that's boring. I can add the ID as well. But you see the point, right? Like now it's quite nice to just have the live coding approach, and you see the changes being reflected, right? And all the typical stuff works, with if and so on and so forth. If you try this out yourself, you will see this already quite sophisticated, and we're using this in a few production projects, so that is just a nice integration. It's not just HTML, it's just templating in general. You can write some, email text with this. You can have some other text-based, some configuration stuff, whatever you would like to have. It is just a nice way that also integrates here as well. Okay, just moving forward, actually, what I want to talk a little bit more about, and that you probably are waiting for, is this native mode, right? Because maybe you have tried this if you used with Quarkus. So what about the whole resource consumption and native and startup time in Quarkus? This is something quite interesting. So I've showed you the build time optimization that Quarkus does. When I just have the plain Quarkus build, right? I can do this again. I can stop this here. I say Maven clean package, and at the end there, it will build my application. Now, because of all of the stuff that is running here, it's a little bit slow. Usually on my computer at home, this runs still in 1 second. So, it doesn't really slow the build down much, but it has all of the optimization. Now, because of the optimization, you will get a lot of savings in a lower resource consumption. So it will save you a lot of, well, mostly memory. You can check out the website for that. It has some comparison of Quarkus just with the JVM, and you don't have to read it. It's just about the size of these things. Compared to a traditional cloud native stack, they compare it to a Spring Boot example. So if you just use Quarkus for the same functionality, you will save a lot just by doing that. I also, maybe have seen this, I run a different JVM. I use OpenJ9. Some of you are fans of Azul and some other providers. That's totally fine. This definitely works. What it corresponds to is just to money being saved, especially in the cloud world, because we can say we run the same stuff than before, just now with less. And that, translates to money, which I know most developers don't really care, like whatever, somebody else pays the bills. But this is a great just example or a great selling feature for then management or saying, okay, this might be an interesting technology. By doing so, you save a lot. And the same is true, and this gets more and more important for CO2 consumption and eco-friendliness. By just running the same things with a technology that consumes a little bit less, you save a lot by this as well, which is, I think, a nice story here to be told as well. Now, if you ask me, okay, then what about the native mode? We can have an even bigger saving. Yes. So what is about the native mode? Because of the build time optimizations, you can compile this down to a native executable that runs directly on your CPU architecture without anything else, and you can use this. Now, the native builds in Java, for example, Graal VM is the most, or Substrate VM is the most prominent example. It is not that easy because it doesn't just work to take your application server or to take your Spring Boot and run it with that. You have to do a lot of optimization and extra building first because reflection doesn't work in the same way with native builds and so on and so forth. There's a lot of things that you need to take into consideration, and Quarkus did all of that. So all of the official Quarkus extensions and the Quarkus runtime will just work out of the box with a native build. You can compile this down to native, but you don't have to. Now there's a trade-off to that in a bigger story. So for example, you will see, well, the resource consumption is even better, even smaller. Yes, with the throughput, it actually depends because a JVM with a JIT compilation that has been heavily optimized in the last years with hotspot and all of these things can work even better. So the throughput might be or will be a little bit higher with the JVM mode actually, and then it is a trade-off as to say, okay, what you want there. The building and the running is much easier in the JVM mode because we're used to the JVM mode, right? If you have a native build, I cannot show it here also with the timing, it will take actually a few minutes just to build the Hello World app. It's really sophisticated, and this will slow it down. So in your typical pipeline, then it's a question whether you want to go native. Spoiler there, all of my client projects with Quarkus run in the JVM mode actually, so you don't have to go native. So Quarkus in a just plain JVM mode gives you a lot of these benefits as well. It's still a JVM, it's still the JVM of choice for your sysadmins, and this is also kind of interesting. So there's a bigger story to be told here. You don't have to use it in a native way, but I want to leave it at that. And the last reason that I have is the great ecosystem and support. I created a lot of issues that have been solved quite quickly. People are very, very supportive. It's mostly backed by Red Hat. There is some commercial support available from Red Hat as well, but that's that. It is just quite nice. But I think for us developers, actually the first point with the development experience is one of the interesting features, because just try it out yourself. You will see it's really, really fun to try it out with this nice dev mode that doesn't make you wait. Okay, so these are my reasons why I think coding with Quarkus is an interesting technology. If you want to learn more about this, I have a lot of content out there. I also have some courses, some video courses that you can check out there. If you want to check out my YouTube channel and other social media things, very happy. We don't have any time for questions, but I'll be around at the conference. I'm very happy to just talk to you. If you have anything, please just feel free to ask. And then thank you very much for your attention.